For this one again, we're going to graph the parabola first. So my axis of symmetry is x equals 1. Substitute 1 in for x. That gives me my vertex. Can find some more points. I know that this parabola opens up, so since it's a positive 1 lead coefficient, I can go right 1 up 1 and then reflect it over here. And that's my y-intercept also. So the reflection of this point here is the y-intercept. So we can't find the y-intercept. This parabola opens up and it's not going to cross that x-axis. So I know that's going to be here and there. What just happened? There are going to be no real solutions because it's not going to cross that x-axis. That's a horrible parabola. So we graph this line. We can see here that the parabola and the line intersect. Definitely here at this point. And it probably intersects at that point, but I'm going to check to make sure because I just sketched the graph really quick. So what I'm going to do is it looks like it intersects at 3 or 3 8s, but I'm going to check to make sure. So I'm going to check that. Oops, not that one. So I'm going to choose x is equal to 3. And substitute it into the quadratic equation. And that is the 0.38. So our two solutions are this point here, which is 2, 5, and then 3, 8. And that looks like a mess. So now we're going to graph linear quadratic systems of inequalities. So we're going to do the same thing. We're going to graph each of them. Again, I usually start off with the quadratic first, and then we are going to shade them. And then with a system of inequalities, we look for the overlap and shading. So again, I'm going to find the axis of symmetry first, which is just 0. The vertex, if I substitute 0 in, it's just 0, 9. This parabola opens down, so it will cross the x-axis. So there are 2 real solutions. And we can factor to find the zeros. Take out the negative. And difference of 2 squares factors into x equals, or x minus 3 and x plus 3. And then I can graph those 2 zeros. And it will be reflected over the axis of symmetry, and that's my parabola. When you're solving equations, I would finish graphing the parabola and find a lot of points because we're trying to find the point of intersection. With the graphing though, I'm fine with just the sketch like that. Just as long as you get the vertex. If there's zeros, you can find them. If there's real rational zeros, you can find them. I mean, you can also use this little trick. If the coefficient of x squared is -1, you can go down 1, right 1, and then reflect it, however you want to graph it. Then remember, because this is less than or equal to, it's going to be a solid line, and then we shade below that vertex. So below it, point down, and we shade everything in there. So the green stuff is my parabola. Now to make it a little bit easier for me, I'm going to do my line in blue. So I go up to 1 and then down 2 to the right one. Again, we don't have to graph this perfectly because we're not trying to find the point of intersection. Try, don't be like super sloppy, but then this is a dash line because it's strictly less than. And then less than, we're going to shade blue, or greater than, we're going to shade above it. So all in here. And remember, we're just trying to find where those two shadings overlap. So where the green and the blue overlap is in this section over here. And again, remember that any point on this boundary line is not a solution because it's dashed. And any point on this boundary line would be a solution to the system because it's solid. And then anything in this purple part will also be a solution because those are the solutions. So then, oops, went off the graph. I'll graph the next one, and you can come back and check your work.